Assalamu alaikum. I welcome you once again to the program of Business Mathematics and Statistics. The topic we shall going to discuss today is testing of hypothesis, which is majorly a part of inferential statistics. To give his expert opinions and views, we have on our show today Sir Nadeem Ahmad Khan. Thank you for joining us, sir. Starting the program formally, sir, what is testing of hypothesis?
Thank you, Sidra. Testing of hypothesis is the most important topic of the subject of statistics. In this testing of hypothesis, we try to test any assumption or statement regarding for the population parameter with the help of the sample statistics.
I observe that we need to understand what is the hypothesis first.
What is hypothesis? Basically, the hypothesis is a statement about the value of population parameter developed for the purpose of testing, or we may say a statement or assumption about the population. Any statement and assumption about the population parameter is the hypothesis.
And it is always about the population?
Definitely, it's about the population. That's why we try to test in testing of hypothesis.
And sir, how can we formulate our hypothesis in a business problem?
Let's say suppose the mean monthly income for salesperson is rupees 10,000. This is the hypothesis for the test. Or we may say that 20% of all customers at a restaurant turn for another meal within a month. This is also a statement or the assumptions of the hypothesis.
And we want to test it for possible acceptance or rejection. So hypothesis is a statement that may or may not be true.
Yes. Suppose, I also give this example, suppose we have the population of the 50 people and assume the population mean age is 50. We take the sample of the 20 persons and the mean sample age of the 20 person is 20. This is basically the sample statistics, and we try to test this 20 years of age with reference to the population age, mean is 50. And when we go for the test and we apply some sample statistics or the sampling tools, definitely the mean age of the population is 50 and mean age of the sample is 20. That's why we reject our null hypothesis. Basically, there is a difference.
Clearly, that is not equal.
It's not equal to the population mean.
Okay. Sir, how do we proceed towards testing of hypothesis? What are the steps involved?
In testing of hypothesis, we have generally the 5 main steps. First is the formulation of the null and alternate hypothesis about the population parameter. The second step is select a level of significance or the level of confidence to test the hypothesis. The third, identify the test statistics in which we formulate and we identify a formula which may apply to test the hypothesis. In fourth step, formulate a decision rule. Here we basically make a decision to accept or reject the null hypothesis. And in last, take a sample, arrive at a decision, and in this step basically we do not reject the null hypothesis or reject null and accept the alternate hypothesis. These are the main 5 steps basically we use in testing of hypothesis. First, the first steps to formulate the null hypothesis. The null hypothesis is a statement about the value of population parameter. Basically, we formulate null hypothesis for the nullification. And if we reject our null hypothesis, definitely we need another hypothesis which we have to be accepted. So the definition of the alternate hypothesis H1 is the notation of the alternate hypothesis, and we generally denote the null hypothesis with H0. The alternate hypothesis is a statement that is accepted if the sample data provide evidence that the null hypothesis is false. Basically, in the first step, we formulate two hypotheses. One is the null hypothesis and second is the alternate hypothesis. For the nullification of the null hypothesis, we have three possibilities. One is, suppose the mean of the sample, mean of the population is 0. This is the null hypothesis. And now we make the alternate hypothesis that mean of the population is not equal to 0, and we may make the vice versa. The null hypothesis is the mean population is not equal to 0, or then we make the alternate hypothesis the mean population mu is equal to the 0. This is the first possibility how we formulate the hypothesis. Here we have another possibility. Suppose the null hypothesis mu is less than or equal to 0, then automatically we formulate the alternate hypothesis mu is greater than 0. The third and the final possibility of the formulation of the null hypothesis, mu greater than or equal to the 0, then automatically the alternate hypothesis mu is less than 0. These are the three possibilities we generally use to formulate the hypothesis for testing of hypothesis. In step 2, this is the most important step in testing of hypothesis. This is the level of significance. And the definition of the level of significance is the probability of rejecting the null hypothesis when it is actually true. The level of risk is so doing. Here in level of significance, generally we may commit the two type of errors. One is the type 1 error, and the type 1 error is rejecting the null hypothesis when it is actually true. This error may be committed in the testing of hypothesis procedure. And the second error is known as the type 2 error, and this is accepting the null hypothesis when it is actually false. So be careful when you design the testing of hypothesis and set the level of significance. And generally the level of significance we use the type 1 error because of the null hypothesis, reject the null hypothesis when it is actually true.
The concept is very similar.
The concept is very similar. And this is the table here we show in the row side. The null hypothesis, generally the H0 is true, and the researcher generally accept when the correct decision is the H0 is true and accept the H0. This is the correct decision in testing of hypothesis. And what is the false decision? When H0 is true and we reject the H0, then this is the type 1 error. And the type 1 error is denoted by alpha. In second, when H0 is false and we accept, basically this is the type 2 error and generally denoted by the beta. And if the H0 is false and we reject the H0, obviously this is the correct decision.
Okay.
Basically the alpha or the type 1 error or the level of significance generally we use to make the decisions. And the type 1 error is reject the true null hypothesis. Basically this is the false and has the very serious consequences if we reject the true hypothesis. And the probability of type 1 error is alpha and called level of significance. And the type 2 error is basically the probability of type 2 error. It means we accept our false null hypothesis, and generally it is denoted by with beta.
Sir, are alpha and beta related in some way?
Yes, there is basically in alpha and beta we have the inversely proportional relationship. If we increase the value of alpha, automatically the value of beta going to be decreases.
Okay.
And we may say the reduce the probability of one error and the other one goes up.
Okay. Sir, how do we decide upon a particular level of significance for testing purpose?
Yes, this is important in testing of hypothesis. What is the level of significance? Maybe it's the 1%, maybe it's the 5%. Generally, the researcher use the level of significance, and these are the following guideline to adopt the level of significance. Choice depends on the cost of the error. Okay, how much error you may afford in your study.
Okay.
Or in secondly, the choose little type 1 error when the cost of rejecting the maintained hypothesis is high. Suppose we give here example, a criminal trial convicted an innocent person. Here definitely the level of significance is very little. In the second example, the Exxon wall sites, the causing an oil tanker to sink. Here in the first example, the life of a person is involved, and in the second example, the money is involved. The researcher decide how much cost he may bear or he may afford in their study. It's according to this, the researcher generally choose the type 1 error.
The cost of making a wrong decision.
Wrong decision, exactly.
And sir, how do we relate hypothesis to acceptance or rejectance regions?
After level of significance alpha, we draw the normal distribution curve. We earlier studied the normal distribution curve.
Yes, sir.
And if our null hypothesis in less than or greater than form, this is generally known as the one-tail test. And if our alternative hypothesis is mu is less than the value of the mu, suppose this is here in this slide, it's 3, we generally use the left tail of the normal distribution. It means we use the negative quadrant of the normal distribution. And if our alternative hypothesis mu is greater than 3, mu has the greater than sign, we generally use the right side of the normal distribution. And in the third possibility, if our alternate hypothesis mu is not equal to 3, then we use both the quadrant, the left and right quadrant, for make the decision.
Because we do not know either it is greater or less.
Greater than or less.
It could be greater or it could be less.
Exactly, exactly. How we select the rejection region of this? Suppose in the first example, mu is greater than and equal to 0 and alternate hypothesis mu is less than 0. Definitely when mu is less than 0, we use the left quadrant of the value, and this is, here is the shaded area is basically the alpha. If the value of the test statistics falls in this shaded area, we reject our null hypothesis. In second example, the alternate hypothesis mu is greater than 0, and the shaded area of the alpha is the right side of the normal distribution. If the value of the z statistics falls in this shaded area, we reject our null hypothesis. In step 3, select the test statistics. This is the important step of the sample testing of hypothesis. Here we decide which type of test we use to test our null hypothesis. In statistics, we have multiple sample statistics or the test available in statistics, but in this program we discuss Z and T test to elaborate the testing of hypothesis.
Sir, how do we decide upon Z, T, F or chi-square?
So basically this is depend upon the sample size. If we have generally the sample size is less than the 50, we generally use the T test, or if we have a larger sample, we use the Z test. Another assumption we make, the population, the sample data is generally the normally distributed. If the sample data is normally distributed, then we use all these parametric tests.
If we have some parameter other than mean to be tested in the null hypothesis, then the distribution shifts.
Yes.
We can use F or chi-square as well.
And
Okay.
to test the variance of the population, we use generally the chi-square and the F test.
Okay.
And for the mean, we generally use Z and T. For the Z statistics, this is the formula for this single population formula. When we have a single population and a single sample mean, we use this formula: Z is equal to X bar minus mu divided by sigma over n. This is the sample statistics. Then the decision rule: reject the null hypothesis and accept the alternate hypothesis if computed Z is less than critical minus Z. This is for the one-tail test.
This is the condition that needs to be satisfied.
Yes, exactly. Or the computed Z, we use the formula and find out the value. This value is greater than the critical value of Z. This is the right side of the normal distribution.
Okay. Sir, how do we decide upon the acceptance or rejectance of a hypothesis on the basis of a p-value?
Sidra, in this modern world and after the introduction of the technology in the statistics and all modern subjects, we have lot of statistical softwares to test the null hypothesis. We have different statistical packages like SPSS, Minitab and other statistical softwares. And with the help of these software, we can easily test of hypothesis with the use of the p-value. And the decision rule is if p-value is larger than or equal to the significance level alpha, we not reject our null hypothesis. And we easily calculate this p-value with the help of the sample statistical packages. And if the p-value is smaller than the significance level alpha, we reject our null hypothesis. This is interpreting the p-value. There are the three examples. In the first example, some evidence H0 is not true. Here we see the p-value lies between 0.05 and 0.10. And if we have the alpha of 0.05, then definitely the H0 is rejected.
0.05 and 0.10 are the ranges of level of significance.
Exactly.
Okay.
In the second, the strong evidence H0 is true. Here we see the p-value lies between 0.05 and 0.01. Here the p-value is less than the 0.05. So we have the strong evidence to H0 is not true.
Strong in the sense because 0.05 is showing only 5% of committing an error.
Exactly.
Okay.
And the very strong evidence H0 is true is here we see the p-value lies between 0.001 or 0.01%. It means 0.1% or 1%. Here the value of p is very small. So this is the very strong evidence we reject our null hypothesis. Now we have to make the decision. And to make the decision, if we reject the null hypothesis, we conclude that there is enough evidence to infer that the alternate hypothesis is true. And if we fail to reject the null hypothesis, we conclude that there is not enough statistical evidence to infer that the alternate hypothesis is true. This does not mean that we have proven that the null hypothesis is true.
So what are some practical examples in business research of a one-tail hypothesis?
For one-tail hypothesis, generally we use the alternate hypothesis for less than and greater than form. And for one-tail test of significance, generally suppose the example is the mean monthly commissions earned by a broker is more than rupees 35,000. Here we use the more than 35. It means 35,000.
That mean is greater than 35,000. Greater than
35. Okay. Or we may use the mean speed of car traveling to Murray is less than. Here we use the less than. When we use like this mathematical notations, less than or greater than, these all these type of alternate hypothesis is the one-tail test. And here there is another example: less than 20% of customer pay cash of their gasoline purchase. Here we also use the word less than. Yes, how we make the decision in one-tail test of testing. Sample distribution of that statistic Z, a right test. Suppose we choose the alpha is 5% or 0.05 level of significance. And with the help of the normal distribution table, we find out the value of the critical value is 0.65. And here in the normal distribution, this value is 1.65 or up to the plus infinity. This is the whole is the region of the rejection or area of the rejection, the null hypothesis.
The rejection region is also called the critical region.
Critical region, you may say the critical region of the testing of hypothesis. And between minus infinity to plus 1.65 value, this whole area is 95% area is the acceptance region of the null hypothesis, or you may say we do not reject our null hypothesis if the value of Z statistics lies between minus infinity to 1.65 area. We discussed the one-tail test and now the two-tail test. In two-tail test, we generally have the alternate hypothesis is not equal to. Maybe the alternate hypothesis or the population parameter have the value less than the population parameter or greater than the population. The example of this, the mean price for a liter of gasoline is not equal to. Remember this, when we use this type of language is not equal to, this is two-tail test. And in two-tail test, we generally don't know the value of the population parameter is less than or greater than the actual value. So we design our critical region or region of rejection in both sides of the normal distribution. And between these two rejection area, the whole area is the acceptance region, or we do not reject our null hypothesis if the value of Z lies between these two shaded areas. And if the value of Z lies between these two shaded areas, we reject our null hypothesis. Otherwise, we accept our null hypothesis.
Okay. Sir, are there any rules to decide upon Z test and T test?
Yes. Earlier we discussed the one thing is the population, the sample size. Another thing is if the population parameters are known. We
Which
generally
population
use
parameters?
Mean, variance and mean. Then we use the T test, otherwise generally we use the Z test. If the population variance is known, we generally use the Z test.
Okay. Sir, it will be better if we take an example and elaborate all of the steps of testing of a hypothesis in it. Okay.
Suppose this is the example of some product manufacturing, and the example is the processors of the ketchup product indicates on the label that the bottle contains 16 ounces of the contents. Basically, in this statements we have our null hypothesis. The claim of the manufacturer is the bottle contains 16 ounces of the contents of the ketchup, and the standard deviation of the process is 0.5. We have also the value of the standard deviation.
This shows that this is the population standard deviation.
This is the population standard deviation. That's why we use the Z test.
Okay.
A sample of 36 bottles from last hour's production revealed a mean weight of 16.12 ounce per bottles. It means the sample mean is 16.12 and the population mean is 16 ounce. At the 0.05 significance level is the process out of the control. This is the value of the alpha, 0.05 level of significance. Can we conclude that the mean amount per bottle is different from 16 ounce? When we solve this example, in this step, first we formulate the null hypothesis and the alternate hypothesis. In this example, the claim of the manufacturer is the population mean is the 16 ounce. to nullification, we make the alternate hypothesis. The mean value of the population mean is not equal to the 16 ons.
That is because we were only asked to test if it was different from 16. We weren't given with the information whether it is less
than
or
the greater than.
Okay.
And in both the cases, we reject our null hypothesis. In step 2, select the level of significance which is given in this example, which is 0.05 or the 5%. In step 3, we select the test statistics, and which is the Z statistics, because in this example we have the population standard deviation, and which is given in this example.
And also our sample size is greater than the regular condition of 30.
Yes. State the decision rule in step 4. We make basically this is the two-tailed test. So we make our critical region between 1.96 and minus 1.96 with the help of the normal distribution, area of the normal distribution table. And step 5, we make the decision. This is the statistics Z, and we use this with the help of this formula. We make the value of Z is 1.44. Here in the formula we put the value of X, which is the 16.12, and the value of mu, and which is 16. And if we use the P value, the probability of Z is greater than 1.44 is 0.1499 for a two-tailed test. And computed Z of 1.44 is less than critical Z of 1.96. And in the second, the P of 0.1499 is greater than alpha of 0.05. So we do not reject our null hypothesis. And we cannot conclude the mean is different from the 16 ons. It means we accept our null hypothesis. The mean volume of the bottle is 16 ons. We also use z-test for the large sample population standard deviation, and which is unknown. Generally here sigma is unknown, so we estimate it with the sample standard deviation S. And if the value of n, it means the value of the sample size is greater than 30, generally we use the z-test, and if the sample size is less than 30, then we use the value of t. This is the example of the t-test, is the similar with the z-test. The formula is almost same, but Sidra, here is the only one difference. In z-test, we use generally the population standard deviation, and if the population standard deviation is unknown and the sample size is greater than 30, then we use the sample standard deviation in z-test. And similarly, we also use the sample standard, the value of the sample standard deviation in the t-test.
Okay, but t distribution and z distribution are different from each other. So we would be having different critical region for t-tests.
Definitely.
And z-test.
For decision making, we have the t table is available in statistical tables. And we also use, there is another step which is the degree of freedom. Generally the degree of freedom is the number of sample size minus the number of restrictions, or we may say the n is the sample size minus the known parameter. If we know the one parameter value, so we subtract from this. In here we have only the mu. Mu is the population parameter, and we have only one value of the population parameter. So the degree of freedom, we need degree of freedom to find out the critical value of the t in the t-test.
Okay.
So that's why the degree of freedom here in this example is n minus 1. N is the sample size and 1 is the population mean. We have only one population parameters.
This concludes our discussion and today's program. We have discussed testing of hypothesis about one sample mean only, but we can also test the hypothesis about two or more than two sample means.